Okay. So this is 7 p.m. It's Monday. I hope everyone is okay and had a nice day. Good morning, Hien. So I, s- I suspect good morning me. So bonjour me. So I guess you hear me because you chat already. So you heard my voice. Good morning, Mai. Um, Good morning, Long. Jin Chao. Jin Chao. Does it tie mean professor or something like this, maybe? Yeah. Sorry for the pronunciation. Okay, okay. Thank you. So I learned one word. Thank you. Thanks to you, I learned something. Okay, so we're gonna get back to what we were doing yesterday. So I uploaded the video for yesterday, so it worked well. So just to say to you that not to forget to record. When I connect, I record. So it means that maybe the 5 or 10 first minutes, there is nothing on the video because this is just before 7, okay? But because I know that I can forget to push the record button when I teach, so I do it before. So you know, it's not if you connect to the video, please go 5 or 10 minutes later. It works well except for the chat, as you say, as I said yesterday. So firstly, I had one question that I did not answer to yesterday just before leaving because it was already 10, so I chose to keep it for today. And maybe it's good as an introduction to our topic. So I hope the person is there. I don't remember, don't recall the name. I think the question was to re-explain what is the difference between zero coupon bond and coupon bond. Okay, so I think it's good for me to use that question as an introduction today because so we can recall. Okay, it's not here yet. I hope that okay, I still begin with this. um, so let me share with you. So the person will be able to look at the video if he wants to hear the answer. But it's good as an introduction to say something about it. So I wrote something in my Blackboard, you know, my Excel that I use in my as a Blackboard, just to check the difference between the two type of bonds. So there are two types of bonds. The first is what we call the zero coupon bond. So this one, there is only one cash flow. Okay, the cash flow is the face value that you receive at the maturity date. Okay, so this is the one we discussed yesterday. Like for example, we can see in the PDF document here, okay, we have this example of this zero coupon bond. So you pay 96 today and you will receive the face value in 1 year, okay? So the IRR, the internal rate of return of this opportunity is actually what we call the yield to maturity. And so it's the return you can earn from the bond, okay? So in the zero coupon bond, since you have no coupons, the only return that you have comes from the difference between the price, the face value you receive at the maturity date and the price you paid, which was certainly lower before because we sell with the zero coupon bonds sell at a discount, okay? Which is not always true with the period we know because sometimes it's not exactly this way because of the crisis, but I won't, because sometimes the interest rates are negative, right? But I won't get into the details of this because I know that you will study that in details later on during the MEBF. So let's say that the normal situation is that you pay a lower price, then you receive a higher amount with the face value. And so the discount rate you use is your yield to maturity is the return on your bond. So that's for the zero coupon bond. And for the coupon bond, so here we have not only one type of cash flow, but two types of cash flows. We have On one hand, all the coupons which are paid at a regular interval, meaning like every 6 months or every 12 months, okay? And you receive also the face value at the maturity date. Okay, so the main difference between the two would come from, and I think this is this was the question of the person yesterday, just before leaving. And so the answer is this: is that it's already the cash flows which are included in the timeline of the coupons, which is different. Okay, so this is something we can say about this. Okay, so that being said, we were actually discussing the zero coupon bond. And so we already talked about this example of a 1 year risk-free zero coupon bond. So I cannot underline the one, but so you see it's 1 year long. Okay, so you pay today and you receive 100 in 1 year. Okay, so the question is, what is the yield to maturity of this bond? Okay, so we did that already. We calculated it, but just to recall and to link that with the little example you had to prepare. So we can see that the yield to maturity can be found by saying that the price is equal to face value divided by 1 plus the rate exponent the number of year. Okay. So in our case here, it's easy because it's exponent 1, right? We don't say it here, but we could say exponent 1. So it's 100 divided by 1 plus r exponent 1 is equal to 96,686. Okay, so that gives us 3.5% for the rate. And okay, so that was for what we did yesterday. And so we said that we can generalize this, right, by saying that the yield to maturity can be found this way. Okay, it's face value divided by p exponent 1 divided by the number of years. Okay, and so you had to apply this to this situation where you have the face value 100,000, okay, 100,000, whatever. And so the price today is 96. So for 1 year, we did that already. Okay. So you had to prepare it for 2 years, 3 years, and 4 years. I don't know if someone have the answer to share in the chat. Just to check that you were able to find it. So okay, so 2 years is 4%. Yeah, that's correct. I recall that. 3 years is 4.5 actually. You can say 4.5. And for 4 years, you have it too. 475, that's it. So let's have a look at the solution. Okay, so here you can see it. So for 1 year, we did that already. So 100 divided by 96.62. Okay, my exponent 1 divided by 1 minus 1. So it's 3.5. And then for 2 years, so please remember that there is only one cash flow to receive from the zero coupon bond. So it's 100, but it's instead of being in 1 year, it's in 2 years. So you have to discount the amount for 2 years, okay? And so since you know the price today, so you do it 100 divided by 92.45, and this is for 2 years. So you make it exponent 1 divided by 2 minus 1 to find a annual rate. And so the annual rate is 4%. For 3 years, we have the same calculation. And so it's 4.5%, as Chang was saying in the chat. And for 4 years, we have 4.75. So we can see that we have a pattern here where with the maturity going up, you earn more on a yearly basis, but it tends to let's say decline, the increase is trying to decline, meaning that it's trying to stabilize. So if I would do something in a graph, I would do something like this, right? It's like this, and then it stabilizes. Okay, so actually this is not by chance, or this is not disconnected from something else, because actually it should recall you what we studied yesterday about this curve in the interest rate. Okay, so you remember we were discussing the term structure of the risk-free interest rates, and we said that, okay, for the normal curve should be like this, the red one after 2008. Okay, so the calculation we just did are, let's say, sort of representative of well, even if it's not the same amount, okay, it goes in the same pattern, which is actually not a by chance, because actually the default risk, the default zero coupon bond, okay, are supposed to be risk-free bonds. Okay, these bonds are the one, for example, from the US treasuries. Okay, so of course the yield to maturity of the zero coupon bond actually represents the risk-free rate. Okay, so if you want, another way to put it is that if later you need to find a risk-free rate somewhere, you can use the return on the zero coupon bond to determine what is a risk-free rate. Because the zero coupon bond, that could be, for example, the US Treasury bonds, okay, are, as we said yesterday, risk-free because there is no risk of default. We can say that the US government certainly will be able to pay, okay? We can make this assumption, it's a reasonable assumption. And so it means that the return which is paid when you buy bonds from the US government or US treasuries is risk-free. Okay, so calculating the yield to maturity of this zero coupon bond is the same thing than calculating the risk-free rate. Okay, so what is the takeaway of this? It's very important for you is that when we talk about risk-free rates, we usually talk about the return on zero coupon bond, especially when it comes from US government, or in Europe, it would be the German bonds. Okay, so because this is the economy which is most powerful in Europe is certainly Germany. So usually the bonds which are totally risk-free are the German bonds. Okay, and so on. So please make the link between the zero coupon bond and this term structure of the risk-free US interest rates, okay? So this is the same, okay? Maybe the numbers are not the same than in the example, but it's no big deal because of course the examples are, the figures are a little bit different, but these are the two same things we are talking about, okay? So please keep that in mind. So we are finished with the zero coupon bond. I mean, we will talk about them again incidentally in some examples, but globally we're done. So of course, what is more difficult to deal with is the coupon bond. Okay, so I remind you that the difference between the two and the fact that we have two types of cash flows for the coupon bond. So we have coupons which are paid at a regular interval, and the face value which is paid, which is one unique cash flow which is paid at the maturity date. Okay. So I come back to my slides, to the slides. Okay, so again, you find it here, coupon bond. So it pays the face value at the maturity, and it pays regular coupon. So it can be every 6 months or every year. It depends on the market. I think in Europe, it would be more every year. And in US markets, it will be more every 6 months. Okay, so it depends on the market. So be careful about this when you do some examples, because if you have to deal with a coupon that pays, a bond that pays coupons every 6 months, be careful about the frequency of your cash flows how you calculate things, and you should have a semi-annual rate as well when you do the discounting. You remember when we did some exercises about time value of money, I said you should adapt the rate to the rhythm of the cash flows. Okay, so if you have cash flows every 6 months, you should use a semi-annual rate. So be careful about this. It's certainly one thing we have to take care about when we talk about bonds. And it's not very difficult because, as if you remember what I said in the beginning of the chapter, we use APR. Okay, so if we have semi-annual coupons, you just have to take the annual rate, you divide it by 2, and so you can discount. Okay. Okay, so that's a question of vocabulary. We talk about notes when it's 1 to 10 years, and we talk about bonds when it's over 10 years, but we will talk about bonds. Okay, so I think I let the answer to this one because we're going to use it as an example. So I hope you can confirm that you have this slide. Do you have it on your PDF? You have it? You should have it normally. If I didn't do a mistake, sometimes I let it. Okay, good. So we're going to work with this example for a few minutes now. So let's be clear about what it is. Thank you for your confirmation. So let's take the US Treasury. And so we have a 5-year, okay, 5-year. Okay, sorry, I was trying something, but it's useless. So 5-year, okay, 5-year, 1,000 bond. So 1,000 meaning the face value, right? That's the face value. 5% coupon rate. Okay, so that's a coupon rate. And semi-annual coupons. So what are the cash flows that you will receive from that bond? Okay, so if you remember again what I said in the beginning of the chapter, the coupon will be calculated as coupon rate times face value divided by the number of coupon payments per year. Okay, so that means that here we have 1,000 times 5%, so that's 50, divided by 2 because we have semi-annual coupons. So it means that we receive 25 every time we receive a coupon from that bond, okay? And because it's 5 years, but because it's semi-annual, you can say that there's 10 times semi-annual coupons that are paid, okay? So if we want to summarize the cash flow that you will receive if you hold the bond until maturity, then you have, okay, at the date 0, you will pay something, and then you will receive 25, 25, 25, 25, 10 times every 6 months. And you will, the last time on the period number 10, receive one unique cash flow, which is the face value of the bond. Okay, so this is how we can summarize the cash flows of a bond. Okay, so usually when I'm physically in Vietnam with you in the room, I usually, many times I go on the board and I draw timelines like this, okay, with the dates and the cash flows, because I think it's very important for me even, but maybe for you as well, when you have an example, an exercise to do or something like this. Firstly, to try to translate the data into the timeline to really realize what you have to calculate, right? It can be also useful to have some marks, right? Because sometimes you can make mistakes in the calculation, but if you have the timeline which is drawn, at least I understand that you understood the pattern of what you were studying. For me, it's very important to do this, just to, let's say, realize what is the situation we're in. So here now it's very clear. We're going to receive 25 10 times, and then we're going to receive 1,000 one time in the period 10, and period 1 to 10 are semi-annual, right? So we have not to forget to use, of course, to consider that we have a semi-annual yield to maturity that's going to be calculated. Okay, so, and when we generalize this this situation, we can say that the coupon bond, which is made of two types of cash flows, the coupon you receive and the face value at the maturity date, we can generalize the pattern of the bond like this. You receive the coupon n times, okay? And usually this is, this is the same amount, okay? And there is one unique cash flow for the face value. Okay, so when it comes to using your calculator, a pen, and calculate, let's say, the price of, of a bond, well, you have actually two things. You have the constant coupons, meaning this is, sorry, this part is, no, okay, I cannot separate, but this part is a constant annuity, okay? So constant annuity of the coupons, and then one unique cash flow, which is a face value that you discount today. And this is how you're gonna calculate the value of a bond. And you can see here that it is said that the price today of the bond, okay, what you are supposed to pay today to buy the bond is exactly the present value of all the cash flows that you expect to receive. And so that's also very important for us, because this is really something we have in a lot of situations. Okay, we have really this idea that we're going to calculate the present value of the future cash flows. And in that case, if it's exactly the price of the bond, okay, the price is exactly the present value of all you will have to receive, it means two things. It means that price is equal to present value of what you receive. So what you pay is exactly equal to what you expect to receive. So it means that this is a zero NPV project. You understand? Because what you receive is exactly equal to the price. Okay? Another way to put it, of course, is that if you want to know the price of a bond, you can determine it by saying, okay, that's the present value of the cash flow I will receive. And I know that it sounds a little bit logical or not very important, but this is very, very important for you, because that's the main principle of what we do together. And that's one main principle of finance. The value of an asset, the value of a bond, maybe later the value of a stock, or what we did in the first chapter, the value of the drug, that was for 17 years. It's equal to the present value of the cash flow you expect to receive in the future. Okay, so that's very important, because it shows that the tools we study together are also here to help us to give a value to assets. So that's why the course is called investment decision and basic valuation, because here we are doing some asset valuation, bond valuation. Okay, so that's very important for you to understand. And this is only possible because we accept that there is only one price for things, with the law of one price, and that the price that will be on the market today for the bond will be exactly the present value of the cash flows we will receive from that bond. Okay, so that's very important. So that means also that the internal rate of return is equal to the yield to maturity. The internal rate of return, which is the real return of an investment, is here called Y in the formula. We can see it, Y. Okay. So just for us to remember. Any question about this? Okay. So let's consider this. Let's consider this this example. So this is the same 5-year 1,000 bond with 5% coupon rate and semi-annual coupons described in in the example. So we get 25, okay, 1,000, okay, and so you can replace 25 here, okay, that's 25, that's 1,000, okay, and that's 10. That's 10. Now the question is, so we're going to search for Y. Okay, so why it's not easy to find, especially if you don't have a financial calculator. So what we're gonna do is that we're gonna have a look at the value which is provided. So we know that the price is 957.35. Okay, so we're gonna try something. So I would like people from Hanoi to calculate the price of this bond if the if the yield to maturity is equal to, let's say, 2%. Okay. So what is the price if so you take y equal to 2, okay, and so coupon is equal to 25, face value is equal to 1000, okay, and n is equal to 10. Okay, so you just have now to calculate. So I would like to find the price in that case, because we cannot find directly y, okay, if we so we have to find a way to do an iterative approach, trying to find one rate which is lower, one rate which is upper, and try to find the price by approaching that with this range. And so I would like people from Ho Chi Minh City to try to calculate P if y is equal to 4%. Okay. Okay, so I'll let you 5 minutes to do it. I'm going to do it on my side on Excel, and we're going to share the solution. Okay. So we have already one solution. Let me, so group 2 is Ho Chi Minh City, so it's 4%. Okay, let me a few seconds to calculate it. No, actually, sorry, Kian, but the okay, sorry, I should have said that. Sorry, for me it was when 2% it's already a semi-annual rate. Okay, so sorry, so you can use it in the calculation. So y equal 2 is semi-annual rate. Okay, and y equal 4 is already also semi-annual rate. So you don't have to. Sorry, it was not clear. So that's correct for Here, I find the same thing, okay? But that being said, that's a good reflex that you have because, of course, and so, okay, for group 5, group 7, so here is okay. Here is okay. Chang is okay. Vuong is okay. Kien, okay. So that's okay now. Yes, that's true. That's going to be 3% at the end of the process. So I would need to have someone from Ho Chi Minh City who confirms the result, because I have only, okay, so we have one result, but I don't have this result. Yes, not exactly. Okay, I don't have exactly the same thing. So 4%, right? 25. Okay. Yes, Chang, I find the same thing. I find the same thing. Oh, by the way, was I sharing my Excel already? Because if I was sharing my Excel, you could see already. Okay, so this is how I did it. It's not maybe very clear. Yeah, I agree with that. Okay, I agree with that. So 878. So we can see. So we can see on the screen. So here it's 25 divided by 2% times 1 minus 1 divided by 102 exponent 10. Okay, so that's for the coupons. Okay, so that's for the coupons. Okay, and this one is one unique cash flow. It's the PV of the face value. Okay. So of course I could do it. I could do it more easily on Excel, but I know that you will not have Excel for the exam. So I try to translate what you should do with your calculator to be able to find it. Okay. So now okay. So people from, I think, Hanoi should have found 1,044.91. No, this is, yeah. Oh, and okay, and because I think, okay, I think Hanoi was for the 2% and for Ho Chi Minh City was for the 4%. So 878. Okay, so what does it mean? Let's summarize. Okay, what we want to find ultimately is what is the rate, the yield to maturity, for which we have 957.35. Okay, what is the y that we should use to find a price of 957? Okay, we cannot find it directly. Yes, we can with Excel or a financial calculator, but I'm not interested in that. We cannot find it directly with a simple calculation. So in that case, what we can say is that, okay, I'm gonna try to calculate two prices, one which is lower, one which is higher. And I know that the price is, the yield to maturity that I'm searching for is in the middle. This is what I'm doing here. Okay, so this is why I ask you to do this. Okay, so how to find y? Well, we use what we call linear interpolation. Okay, so linear interpolation. So what does it mean? We find a p, a first value of p for which p is lower than 957.35. Okay. We find a second value for which p is higher than 957.35. Okay. And so we know that y is in the middle, okay, of these two values of y used to calculate the two prices, the 2p in the previous steps. And so we make a sort of an average. Okay, so if y is equal to 2%, p is equal to 144.91. If y is equal to 4%, p, so it's not 14, it's 144. Okay, if y is equal to 4, p is equal to 878.34. Okay, so if we go like this, we can say yp. Okay, so if y is equal to 2%, we have this one. If y is equal to 4%, we have this one. Okay, so what we are searching in this one. Okay, so what is the value of this percentage if the price is 957.35? Okay, is it 35 by the way, or is it something different? 35. Okay. Okay, so what we want to determine is this one, right? What the yield to maturity, which is okay for 957.35. We don't know it yet. Okay, so what we're gonna do, it's like binary search. Yes, I think this is how we can call it. In French, we say règle de trois. It's I think it's also, we could say, I think it's also applying the Thales theorem, right? I think. So yes, it's a simple financial simple mathematical. So we consider this is proportional, right? So we're gonna say, what is the distance here between this one and this one? It's 144 minus 957. Okay, and so the distance here is 957. Okay, so that's the distance between 2% and y. And this one, that's the distance between y and 4%. Okay, this one, that's the distance between the two, and this one, like this. Okay, so maybe, I don't know, I try to explain, but maybe it can sound complicated, I don't know. The thing is, the y you have to find will be equal to 2%, okay? plus 4% minus 2% times 87.56 divided by 144.91 minus 870.834. Okay, so the distance between 2% and y on one hand. Okay, so that's 87.56, and the distance between 2% and 4%, okay, which is 86.56 plus 79.01 or 144.91 minus 878.34. Okay, and so we find the result. Okay, so the idea is to say that we, like in a binary search, as you say, we're going to consider that this is proportional. Okay, the distance between 2% and y, which is 87.56. Okay, and the total distance. So we know that 2% of distance. Okay, so that represents 2%. Okay, so that represents a part of the 2%. Okay, so what is the distance I have to do to go from 154 to 957? This is 87. So that represents the percentage we are searching for. And we know that when we go from 2% to 4%, okay, we go from 144.91 to 878.34. So we do a total distance of, I don't know, which the addition of the 2 here. So this is 71 plus 86. Okay. Another way to put it is that 166.58, it represents 2%. Okay. So how much represent 87.56? Okay. This is how we can put it. Maybe it's easier. 166.58 represent the distance from this one, okay, to this one. Okay. So when I do this distance, we do 2%. Okay. So the question is, how much of this distance I've been walking by if I want to reach 957? So this is, I know that 166.58 represent a total distance of 2%. How much of this 2% represent 87.56? Okay. So it's 2% divided by 166 times 87. Okay, so that represents 1%. Okay, let's say 1. And I had at the beginning 2% already. Okay, so it means that it's y is equal to 2% plus the 1% I just found. So it means that the y we're searching for here is equal to 3%. Okay, and so that represents the yield to maturity of our example here. So I'm not sure it was very easy to understand. So I am finished with this explanation. So do you have any question in the chat for me? So maybe I can explain a different way, or I've been trying to find different ways to explain. It's like a proportional rule, right? To find the missing yield to maturity, we will consider that the distance between the relationship between 144 and 878 is linear, right? So we will consider that the rate will increase proportionally to how the price is decreasing. In the exam, do we have to explain all this or just find out the why? Well, if you find the why, it's okay, huh? So you can, you don't have to, okay, another way to do it is to make trial or error, right? So you try with different rates and you find, and once you find the rate, it's okay. So here it's just an alternative method to do it. So no, you don't have to explain that in the exam. You just explain that you try with the rate and you find, but you don't have to detail all this. This is just if you don't have, this is just if you want to go with a linear interpolation. Do you have another question? No? Okay. So I have a simple question for you now. Let's forget mathematics and let's, sorry, let's finish the example first. So we go back to what we have in the slides. So the question was, what is the bond yield to maturity if the price is 9.57? So we just found it. So we found 3%, right? 3%. But do not forget, okay, can I do like X, da, 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 da? Yes, you can. Yes, you can. I think you can. 2% times plus 4% divisé par 950. Let me try this in Excel. Alors, 2% fois 1414 plus 4% fois divisé par 957. I think it doesn't work because because 2% and 4%, it's already okay. Okay, I understand what you try to do. 2%. No, I think it's not correct to do so. And so I forgot to multiply 2 in the delimiter. So 2% plus 4% divided. Okay, I understand what you try to do. I'm not sure. I'm not sure because okay, 2%. So your logic is to say 2% is for 144, 4% is for 878. Okay. No, I don't think it works. It works this way. I assume you can achieve the same result if you can calculate the proportional distance for y to 4, right? Yes, exactly, exactly. This is what I was trying to say. So maybe I was not clear, but I don't see here, and so maybe I need to check a little bit more. But yeah, okay, I understand. Okay, no, I don't think so. I don't think so because you. No, I don't think so. I don't think so. You can do it this way. Sorry. I don't see, but okay, we 2% divided by. And then what do you do with this 0.2876? Okay. No, I don't think so, Kian, as well, because okay. So what you okay. So what we do is we do 2% plus 2% times 144 minus 978. Okay, no, sorry, we do this 2% plus 2%, 144 minus 957 divided by 144. So this is what we do. I think it answers to both your questions. This is what we should do. This is what we should do. So let me put that in Excel. And sorry, it's not easy to copy past. What is my mistake here? Should be okay. I don't understand why it doesn't. Do I miss a parenthesis or something? Okay. So 2%. So this is okay. I'm not going to check. It's okay. So it's 2%. So what you were doing, Kian, so so it was correct to say that, okay, so so 2% plus, yeah, 2% plus, yes, that's correct. That's correct. Now what you have in the chat, Kian, is correct. So that's it. That's the way it should work. So I copy past what you just have. Okay, so that is okay. That is okay. So it means that I agree that finally it's not exactly 3% when we do this, which actually is quite interesting because the real result is 3%. Okay, but when we do this, let's say a linear interpolation, or how you call it, linear calculation or whatever, proportionate distance, okay? So it's not exactly 3%, but 3.05, okay? So it means that this one is not so precise, okay? So what we do here is not even so precise compared to trial or error, or using, you know, a very complicated iterative process. But it's a sort of a approximation, which is good enough for us because it gives us an idea about what is the rate if we consider that there is a linear relationship within the 2%, okay? This is what we do, huh? We consider that we know that when we say 2% plus a part of the other 2%, we say it's at least a 2% because we know that when we are 2%, it's 144, so it's more than that. And for the rest, between 2 and 4, we make a proportional rule, okay? So compared to what was done earlier, I said it was not good. You were considering in this earlier that the proportional is from 0 to 4%, when here we consider only it's from 2 to 4%, that we have something which is proportional. Okay, but that is correct, of course, huh? That is correct. Okay, I think so. I think we should move on because we've been in the calculation. So I don't want to. I understand that some people will say, "Wow, okay." So don't worry, huh? It's not so complicated. Okay, so I'm going to share now the PDF document. So we find finally that it's 3%, the rate, okay, or 305 if we follow the calculation by Kian. And so it means that the 3% we have here, do not forget it's a semi-annual rate. Okay, so do not forget to multiply it at the end of the day to say, okay, semi-annual is 3%, so annual is 6%. Okay, so the rate, the annual rate of maturity, yield to maturity is 6% for this case. Okay. Just now coming back to, let's say, some analysis of what we do. So as we can see, when the rate is 2%, we got a price which is 144, right? And when it's 4%, we get a price which is 878. Okay, so just realize how it goes. When the yield to maturity is going up from 2 to 4%, the price of the bond is going down from 144 to 878. Okay, so keep that in mind. Mathematically, it's coherent because, of course, when the Y we use as a discount rate is going up, the price is going down. That's correct. But also, economically, what does it mean? It means that when the price of the bond, so when the rates are going up, the price is going down. Okay, so there is an inverse relationship between the price of the bond and the yield to maturity. So that's interesting for us to remember. Okay, so let's do it again now. So we take the same bond, okay, but now it's easier because we are given the yield to maturity. It's the yield to maturity now 6.30, okay? So it means that semi-annual, we have a yield to maturity, which is 13.15, okay? So what is price in that case? So this one is easy to do because it's not to find the yield to maturity, it's just to find the price. So please recalculate for me the price of the bond is the yield to maturity is 3.15 now, okay? So I'll let you 2 seconds to do it. And just think about if the price of 957 is for 3%, okay? So now we have 315. So should we find a price which is higher or a price which is lower? Okay, if we say that we have an inverse relationship between Y and P, if Y is going up from 3 to 315%, then we should find a decrease in the price. Okay, so we should find a price, you should find a price which is lower than 957. Okay, so check that for me. Yes, that's correct. That is correct. 944, 944, 98. So the formula by Vuong is correct as well. So that's 944, 98. That's correct. I'll let 1 or 2 more minutes for your colleagues to have the opportunity to find a solution as well. Okay, so we got already a few good answers. Yen, Kian, Vuong, Chong. So you got the detailed calculation. I'm going to copy paste the formula which is given by your friend Vuong. Okay, so this is what the formula is, this one, right? So it's here, 3.15. So when we have 3.15, we have this formula. So 25 divided by the rate times the discount factor for 10 period plus 1,000 divided by 1,015, 0,315 for 10 period. Okay, so we got on one hand the present value. Sorry, I didn't. So we have the present value of the coupon here. And so we have the present value of the face value here. And so it's 944. So we are not surprised. We are not surprised to find that so just correcting my formula here for later. Okay. So we are not surprised. The price is going down compared to if the value is 3%. So it goes from 957 to 944. Okay. So coming back to the slides. So we have this, right? 944.98. And so it means that we have, again, so 6.3 is the APR with semi-annual compounding. I thought that it already is a rate for 6 months. No, 3.15. 3.15 is for 6 months. 6 months. So 6.30 is for annual. Okay, I understand what you mean. Okay. So yield to maturity has increased to 6.30. We have to understand that it's an annual rate. It's an annual rate. Okay, and then they say that we to be able to calculate the semi-annual rate, we're gonna take an APR with semi-annual compounding. But this is an annual rate. Usually, the rate which are provided are for annual rates. Okay, so let's move on. So what we got from here is that we have an inverse relationship between the price and the yield to maturity. So when the yield to maturity goes up, the price goes down. Okay, so let's go a little bit further than that now. Firstly, in terms of vocabulary, what we say is that a bond is selling at a discount if the price is less than the face value. Okay, so that's the case when we have, for example, in the previous example, 944. Okay, 944.98 is lower than 1,000. So the bond is selling at a discount. Okay. On the contrary, we have a bond which is selling at a premium if the price is greater than the face value. So here, for example, we have this. When we calculated earlier, the value of the bond for 4%. Okay, so for 2%, sorry. So we have 144.91, which is higher than the face value. Okay, higher than the face value. And here we have something which is lower than the face value. Okay. So this one trades at premium. And this one trades at a discount. Okay. At a discount. Okay, so the price is at a premium when it's higher than the face value, and we can see that it happens when it's lower than 3%, right? Okay, or 2.5 even. Okay, let me rephrase. Let me come back to the slides. So a bond will sell at a discount if the price is less than the face value. Okay, a bond will sell at a premium if the price is greater than the face value. When does it happen? Well, actually, the bond price will be greater than the face value, like for example, 144. So it's at a premium when the coupon rate is higher than the yield to maturity. Okay, so for example, in our Excel file, we know that the coupon rate, annual coupon rate, is 5%. Okay, annual coupon rate is 5%. So the semi-annual coupon rate is 2.5%. Okay, so when the yield to maturity is lower than the coupon rate, it trades at a premium. which is logical, right? When, on the contrary, the yield to maturity is higher than the coupon rate, it trades at a discount. Okay, the price is less interesting. So this is what we have here. Okay, let me summarize. When the bond price is greater than the face value, it means that the bonds trade at a premium, and it means that the coupon rate is higher than the yield to maturity. Okay, so that's a general rule. On the contrary, when the bond price is less than the face value, we say it trades at a discount, so it means that the coupon rate is lower than the yield to maturity. So is it logical? Well, the coupon rate is the rate which is offered by the bond. In our case, it's 2.5 semi-annual, okay, or 5% annual. And the yield to maturity sort of represents the situation of the interest on the market, okay? So if we have a coupon rate that pays 2.5% and the yield to maturity is 2%, meaning that the rate on the markets actually, or nowadays, is 2%, it means that our bond is, let's say, more interesting than the current situation of the market, because it pays 2.5 when on the market today you can be paid 2%. Okay, so if your bond pays a little bit than what is the current situation on the market, of course it gives a higher value to the bond, so the price will go up. Okay, on the contrary, if the coupon rate 2.5 is lower than what is currently the situation of the interest rates on the market, let's say 3%, it means that your bond is not so much interesting compared to what you can find on the market. So if someone would like to buy your bond, he knows that he will receive a coupon rate which is lower than the actual, that the current rates available on the market. So the person will say, okay, your bond you're trying to sell me is not very interesting for me compared to the current situation on the market. So why should I buy yours when I can find a better one on the markets currently? Then you say, okay, I agree with that. So I'm gonna sell it at a discount to compensate the fact that the coupon rate which is provided for this bond is lower than the current situation on the market. Okay, so this is what we have in our situation here. Okay, so we know that the coupon rate of our bond is 5% annual, so 2.5 semi-annual. Okay, and now we know that the yield to maturity, which represents, let's say, the current situation of the interest rates on the market, is 2%. Okay, so it means that the market is paying 2% nowadays. Your bond is paying 2.5. So yes, it's more interesting. So the value of the bond will certainly increase. And so the price will be certainly higher than the face value. So 144 is higher than 1,000. Okay. On the contrary, if suddenly the situation on the market is that semi-annual, we have a rate of 4%, which is an annual rate of 8%. So it means that currently the market offers better conditions for the bonds than the one which is offered by your bond. Okay, so it means that your bond is still offering 2.5 semi-annual, 5% annual. Okay, and 2.5 compared to 4% is of course less interesting. So the selling price of your bond will go down and the price of the bond will not be very good. So it will sell at a discount. Okay, so maybe this below, forget the calculation. That is more important than the calculation. That the general relationship between the bond and the coupon rate. So again, let me say it again. When the bond price is higher than the face value, so it means that your bond is more interesting than the current situation on the market. So it certainly means that your coupon rate is higher than the yield to maturity and your bond trades at a premium. If your bond has a value which is less than the face value, it certainly means that this bond is not very interesting currently. So the coupon rate which is offered by the bond is certainly lower than the yield to maturity. And now that I summarize all this, I can just finish with the at par situation. So this is when the coupon rate is exactly equal to the yield to maturity. So let's say for our bond, 5% annual, 2.5 semi-annual. So 5% annual, and this is also the yield to maturity of the market, 5%, okay? So it means that your bond is exactly in the trend of the market. So the price of the bond will be equal to the face value, okay? Is that clear for this part? Do you have any question? No? Okay, so let's make an example then. So we have three 30-year bond with annual coupon payments. One bond has a 10% coupon rate. The second one has a 5% coupon rate, and one has a 3% coupon rate, okay? So if the yield to maturity of each bond is 5%, what is the price of each bond for 100 face value, okay? So which bond trade at a premium, which bond trades at a discount, and which bond trades at par. So I'm going to share with you the Excel file, and I'm going to, a little bit advance the calculation. So for the first one, we have, sorry, I have to find my PDF document somewhere. I don't see it anymore. Okay, it's here. Okay, so I got my data now. So the first one is 10% coupon rate, okay? So all the three of them are 30 years long. Okay, 10% coupon rate, 5% coupon rate, and 3% coupon rate. Okay, and so the face value for everyone is 100, right? 100. Face value is 100. So 10% coupon rate for 30 years is going to be, so the coupon will be 100 times 10%, okay? So it's 10. Okay, and so the price of the bond will be equal to the coupon, 10, divided by, so the yield to maturity, it remains the same, right? 5%, okay? Plus, so times 1 minus 1 divided by 1.05 exponent 30, okay? Plus 100 divided by 1.05 exponent 30. Okay, so that will be the price for the first one. So coupon of 10 for 30 years and the face value. If the coupon rate is 5%, so it means that the coupon will be 5% here. Okay, so it's going to be 5, right? And so the formula will be exactly the same, except that it's going to be 5 instead of 10. So what is the name of 3.15? I mean, how do I call it after being divided? It's the semi-annual yield to maturity. Semi-annual yield to maturity. Semi-annual yield to maturity. And so for the last one, coupon of 3%, okay, so that's 3. And so here, it's like this. Okay, so we got three bonds to calculate, and we want to know the price, okay? So remember that what we are trying to illustrate here is that there is a, if the coupon rate is higher than the yield to maturity, the price of the bond will be at a premium. If the coupon rate is equal to the yield to maturity, the price of the bond will be equal to the face value. And if the coupon rate is lower than the yield to maturity, it means that our bond is not very interesting. And so that means that the price will be at a discount, okay? So knowing this one, 10% coupon rate. So I would like to see in the chat, does it give at a premium, at a discount, or at par? 10%. So premium for the first, okay, so we have already some calculation by Kian at a premium, okay, because the coupon rate is higher than the yield to maturity, because the yield to maturity is 5% of the time, okay. 5% coupon rate, so it's at par. So what is the value? What is the price of this bond already? Do we have really to calculate it, or can we know the price? What is the price of this one if the bond is at 5% yield to maturity with a 5% coupon rate? What is the price of it? Face value, okay? So that's 100. Okay, so this one we do not have to calculate. And 3% coupon rate, so it's 3%. So of course it should be at a discount. Okay, so maybe to save time, Hanoi people, you try to calculate the first one, and Ho Chi Minh City people, you try to calculate the last one, okay? And we have already some answers by Kian, which are correct, so you can check, okay? But I let everyone a chance to do at least once, okay? So Hanoi people, you do with a 10% coupon rate. And so it's at a premium, so you should find a P which is higher than the face value. And on the contrary, the blue one, coupon rate 3% for Ho Chi Minh City people, you try to calculate it, it's at a discount, so you should find a price which is lower than the face value. Okay, so I'll let you 2 or 3 minutes, and so we got already the answer by Kiana, but I would like to see other answers to check that everyone has the time to do it. So do not hesitate to share your answer in the chat, so I can see that it's some feedback for me. So thank you, Chang. So group 8 must be Hanoi, right? Hanoi, because Hanoi is 5 to 8. And so, yeah, so that's correct. 178.6 is 86. So that's correct for this one. 78.86. Okay. So this one is 100, and this one. So we need some answer from one person from Ho Chi Minh City for the 3% coupon rate. So I'm just waiting for one answer from Ho Chi Minh City people. So I think I have 169.25. I think it's correct, right? Yes, this is also what Kian had. So 69.25. Okay. So I think we have it. I think we have it. Okay, we have a second answer by Chang. So that's perfect. So we can see. So again, the yield to maturity for everyone is 5%. Okay, so the assumption in that case is that the yield to maturity is not changing, right? We consider it constant for the moment for the calculation. And so we can see the illustration of what we were just saying. So if the yield to maturity, if the coupon rate is higher than the yield to maturity, it trades at a premium and the price will be higher than the face value, because this bond pays 10% when the current situation on the market is 5%. So it's a more interesting asset than what the market is currently offering. So if you want to buy this bond that gives you 10% instead of 5% given by the market, then it means that you will have to pay a higher price. If the coupon rate of your bond is 5%, which means that it's exactly the yield to maturity, meaning the current situation of the interest rates on the market. So it means that your bond is reflecting the situation on the market nowadays. And so the price of the bond will be equal to the face value, because the coupons you will receive will exactly compensate the time value of money, right? So it's gonna compensate it. So voila. And the last situation, if the coupon rate you offer on your bond is lower than the yield to maturity, 3% is lower than 5%, it means that your bond is not very sexy. So you have a situation where the price of the bond will certainly be lower than the face value, and this is what we find. We find 69.25 instead of 100. Okay, so that's it for the calculation. So I think we have the calculation also in the slides. So we can see the same thing here, okay? And that's it. Okay, so that's it. Another thing I just wanted to conclude about, about the calculation we did earlier that could appear to be complicated with linear interpolation and everything. Again, you can just try with several values of the yield to maturity to see what is the price, so trial or error, right? And now you have a better idea how to do it, because you know that if the price which is provided, like in the previous example, it was 957. So knowing the property we just discussed, you know that, okay, P is 957. So it means that this bond is trading at a discount. So it means that the coupon rate, it means that the bond is not very interesting. So it means that the coupon rate must be lower than the yield to maturity. The yield, so the coupon rate is 2.5. So I have to try with a yield to maturity, which is higher than 2.5. So you don't have time to lose trying with 2%, 1%, because you know it's already more than that. Okay, so it helps you already to imagine what could be a good try for the Y when you want to try it. Okay, if you don't have other solution to do it. Okay, so this example was about what we do if we have a constant yield to maturity, 5%, and what is the impact on the price of the bond. I think we spent some time on it. So I think it's okay now. Okay, so I think it's 8:23. Maybe it's a good timing to have the break now, 20 minutes. And so we move to the next topic just afterwards. So let's meet in 20 minutes and we move to the next topic. Okay, so enjoy your dinner if you have dinner now. Okay. Okay, thank you. Okay, thank you very much. Okay, see you in 20 minutes. Okay, so we are back for the second part of the course today. So can you hear me? Somebody can. Okay, thank you. Thank you very much. Okay, so let's move to the next topic now. I introduced that already when we did the first course together about the just before and just after payment, what it happens. Okay, so globally, well, about the time and bond prices. Holding other thing constant, a bond's yield to maturity will not change over time. Okay, so if we forget that it can change, what's going to happen is that the price or the price of discount or premium bond will move towards the par value over time. Okay, so it's going to be like this. If we want to see, okay, it's going to be like this. Okay, we have the three bonds that we were discussing: 10% coupon rate, 5% coupon rate, 3% coupon rate, and a zero coupon bond. And all of them, you can see they're gonna, 180 is not so far from 179. Okay, this one 100, this one is 69. We just did these ones. Okay, we can see that the more we're gonna go close to the maturity date, the more we're gonna go to the face value. Okay, so this one gonna go to 69 to 100. This was gonna go down from 179 to 100, because the more we go closer to the maturity, the more coupons are paid. So the fact that there is a difference between the coupon rate and the yield to maturity will not influence that much. But we can see that within the year, we discussed that already, we have increases and sudden decrease when we have the moment of the payment of the coupon. Okay, so let's just discuss that with this little example. Okay, so I would like you to work on this one. So consider a 30 years bond with 10% coupon rate, annual payments, and 100 face value. So this is the one we discussed already. So this is the one which is 179 something, I guess. What is the initial price of this bond if the bond has 5% maturity? So let me just be clear. This is something we did already. So this is this one. Okay, so this is this one. So let's say that I put it again here because it's a new example. Okay, so first question, what is the initial price of the bond? This is 176. It's not 179, sorry, it's 176.86. Okay, so that's the first answer to the question. Okay, and so this is the initial price. So this is at the date 0. Okay, so now if the yield to maturity is constant, 5%, what will be the price immediately before and after the first coupon is paid? Okay, so I let you 5 minutes to try to do this. Imagine that you are not at the date 0, but you are just before the date 1 or after the date 1. Okay, so try to imagine what could it be and what could be the relationship in the price. Okay, so again, we are here at the date 0. Okay, so we are here at the date 0. Date 0, 176. Now, what is, let's say, if I were you, I would do this way. Firstly, what is the price at date 1 just after coupon is paid? Okay, and then only I would do just before coupon is paid. Okay, this is what I would do if I were you. Okay, what is the value of, what is P just after the first coupon is paid? Okay, what is changing? And then what is the value of the price of the bond just before the coupon is paid? Coupon 1 is paid. Okay, so I let you try to find the solution to these two questions. I let you 5 minutes and we discuss the answers. And of course, if you have one answer, you can share in the chat so I can see that somebody found, or I can see how many students have found. It's good for me to have some feedback. Since I cannot see you and I cannot go among you guys to check behind your back what you are doing on your paper, I'm a little bit blind here, so I really need some feedback so I can see that you're making progresses, hopefully. Yeah, I think this is correct. Yeah, that is correct, John. And yes, that is correct, before and after Kian. Okay. A few more minutes for your colleagues. 5 more minutes for your colleagues. Yeah, your logic is correct, Kian. So Hien, yes, 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 that is correct as well. That is correct as well. Before, yeah, plus 10. Okay, yeah. So that is exactly correct what you say, Hien, as well. 2 more minutes and I give the solution. Do not hesitate to share your results just as a feedback. So any other answers? I know that some of your colleagues already gave the answer, but it's just to check with me, or at least you can say yes if you found the solution, just to see that I have at least a few people who are finding the answer. Okay, so I'll let you more time. Okay, so I don't see other answers, so but I need to move on. So I hope you have you had the time to calculate the elements. So let me summarize what we have. So consider a 30-year bond with 10% coupon rate, annual payments, $100 face value. What is the initial price of this bond if it has a 5% yield to maturity? So this one we calculated already. It's 178.80 something. If the yield to maturity is unchanged, what will be the price immediately before and after the first coupon is paid? Okay, so we discussed these topics already. I prepared some answers here. So for this first question, we had 10% coupon rate. Okay, so we have a 10% $10 coupon. Okay, so the date zero, we calculated that before the break, right? So we have $10 coupon, 5% yield to maturity, 30 years. So 176.86 at the date zero. Okay, so that's at the date zero. Then you were asked to calculate what is the price at the date one after the first coupon is paid. Okay, so that's P1 after. Okay, so what happens P1 after? So if we are P1 after, it means that we just receive one coupon, so we don't talk about this one anymore. It's already some cash that we have in our pocket, right? So maybe we can invest that somewhere else and or whatever. So it's certainly not a cash that we expect to receive from the bond anymore, not anymore. So what do we expect to receive from the bond now? Not that we just received the first coupon. Well, the next time we will receive something, it's going to be in 1 year, okay? Next cash flow in 1 year. Next coupon to be received in 1 year, okay? Okay, so we can apply the constant annuity, but only for the 29 coupons left, okay? Okay, and the face value in 29 years instead of 30 years now, okay? So this is why we do this. We do the same formula, but we have an exponent of 29 instead of 30 for both the coupons and the face value, okay? So it means that here we have a value of 175.71. So that's the value after. And so maybe you were surprised. I said to you, maybe it's easier to do after the P1 after before doing P1 before. Why? But actually, because as Kian and Hien well understood, we can reconstruct the value of P1 before from the value of P1 after. I think we did that already in some time value of money exercises. So the P1 before is just P1 after plus the coupon which is just paid. Huh? This is what Kian is saying in his chat, in the chat. Before is equal to after plus coupon, okay? And you have the mathematical expression with Hien, who just adds 10 at the end of the formula, okay? So this is what I have here also. P1 before is P1 after plus the coupon. So we just take 175.71 plus 10. Okay, what does it mean? It means that the bond is about the present value of the cash flow you expect to receive. So you're gonna receive a coupon in a few seconds or a few minutes. Okay, so it's already calculated at the present value, 10, plus all the thing we calculated before, meaning the present value of the 29 coupons to receive plus the face value, 29 years. Okay, so P1 before is just P1 after plus the coupon. We did that already with an exercise about loans, 12,000 and so on. So hopefully, I hope that now it's more clear for you what is the difference before and after. Okay, so that's interesting because it shows that you have well understood, let's say, the timing of the cash flows. And of course, it can be for bonds, but it can be for something else. Now, I just wanted to also show that there is an alternative way to calculate this 185.71. P1 before, it's P at the date 0, but in 1 year. So P before is 30 coupons to receive plus the face value to receive, okay? So it means that it carries the same cash flows than P0, okay? The same thing than P0. So this one, P before, P1 before, it's the same thing than P0, but just 1 year later, okay? So P1 before is just P0, but 1 year later. So P1 before is P0 capitalized in 1 year, okay? So it's just 176.86 times 1.05 exponent 1, as I just said here, okay? So this is a second way to calculate the P1 before. It's P0, because it carries the same cash flows than P0, but it's just 1 year later in time. So we just have to capitalize P0 in 1 year. Is that clear for everyone? Can I have some feedback in the chat, please? So I can at least know that you hear me, and I feel a little bit alone for a few minutes now. Just would like to be sure that you can hear me. Okay, okay, thank you. Okay, so this is it for this example. So when we come back here, we come back to this, thank you, Kong, thank you, Chang, thank you, Dong. So we have the summary of what we just did here, right? Thank you, Ha. So we can see this bond we just discussed, right? 179. Okay, so it goes up to 185, and then it goes down to 175. Okay. So it's like a tooth, right? A tooth pattern. So within the year, we have an increase in the value of the bond, which is linked to what we call the accrued coupon, right? The accrued coupon. So that's why also we say that we have a dirty price and a clean price for the bond. The dirty price is including the accrued coupon, and the clean price is without the accrued coupon. Okay, so if you buy back the bond within 1 year, you will have to pay to the person who's been holding the bond for 6 months half of the coupon the person expects to receive next year, okay, to compensate. So that's why you don't have this pattern here in purple for the zero coupon bond, because of course within 1 year there is no variation due to the accrued coupon, because by definition this bond has no coupon. Okay, so we see only this pattern within the year for the 3 bonds for which we have a coupon which is paid. Okay, but if we forget the within the year trend, we can see that the pattern is that it goes down, okay, towards the face value. For the blue one, it stays around 100 for the one which is at par, and for the bond which is at discount, it tends to go up towards the face value with the time, okay, because the more years are passing by, the lower will be the disadvantage of having a coupon rate of 3% instead of 5%. Okay, so please remember this, which is say just before the example. Okay, holding other things constant, the price of discount or premium bond will move towards par value over time. Okay, so that's important. So that's it for this example. Okay, just to conclude about the bonds. So there is obviously an inverse relationship between interest rates and bond prices. Okay, when the interest rates go and bond yields rise, the bond prices will fall. And on the contrary, when the interest and bonds yields fall, the bond price rise. So this is something we, I think, identified already. So maybe this is one of the takeaway of the day, right? For those of you who don't know bonds very well. We just have an illustration which is from the book. So it's chapter 6, figure 6.2. Hopefully this is the same number in the version number, the edition number 4, but I think it's up to date. And so here we can see that now it's like we add a new assumption to what we did before, okay? What we did before is that we say that we have the yield to maturity, which is 5%, okay? And so you have the value of the bond here, okay, the bond price, okay? So I think the one we are talking about here is the one which is zero coupon bond, okay? So we have 29 or something like this, a value when it's 5%. And so when the yield to maturity go up, see the price of the bond goes down, okay? And on the contrary, here, for example, sorry, I cannot point here, we can see that you have the opposite effect. When the yield to maturity is going down, the price is going up. And you have a sort of a corridor, which is actually on the chart, okay? And we can see that the value, the blue line, which is a little bit volatile, accidental, we can see that it goes up and down, but stays in that corridor, yellow being when the yield to maturity is equal to 4%, and purple when it's 6%. So we can see it stays in this corridor. And the green line, of course, represent what would be the value of the zero coupon bond if the yield to maturity is constant to 5%, which was our initial assumption. So basically what we can say as a conclusion here is that the green line represents what we were discussing before. So it's a plain line, okay? And the blue line represents how much ups and downs we have compared to the green line, which is due to the variation of the yield to maturity, meaning the interest rates on the market. Okay, so the trend is not changing. We go up towards the face value, but on the short term we can have some accidents because of variation in the interest rates. Okay, so that was for the chart about what happens if the yield to maturity is not constant to 5%. So this is what happens. Just to finish with the bonds, we were actually discussing this yesterday, I think, about the ratings. I think one student, one person among you said, "Are we talking about the ratings and stuff?" And so this is what we are doing now, very quickly, but still. So because it's linked to the risk of the bond, okay? Because as I said, when you buy a bond, you want to be sure to receive the coupons and the face value, okay? But sometimes it's not so sure, right? It depends on who is issuing the bond. Is it an entity which is quite solid, or is it an entity which is not solid? Okay, so that's why we have rating agencies that classifies the bonds into two main categories, what we call investment grade bonds. Okay, so the investment grade bonds, the first one, is a category of bond which is not risky because it's supposed to be quite, the entity are quite solid. On the contrary, what we call speculative bonds is bonds for which we can expect to earn more money, but which are also more risky. So we also call them junk bonds or high yield bonds, because the rate you can expect to receive, the coupon rate can be higher, but you know what? It's not certain that you will receive this coupon. Okay, so of course it's not so easy. So here, this is from the book, and you get a description from Moody's about the rating. So from AAA, AA, BAA, BBB, and so on. And so you can see what is a descriptive of what is the quality of the bond. Okay. So just for you to have a look if you want. So of course, the lower we go, so speculative bonds will go from BB to C or D. So for which we have a big risk of default. And so what does it mean? It means that this is another takeaway for today, is that of course, when the bond has a less good rating, you must give a higher coupon rate, right, to compensate. Because if your rate is not good, it means that the market is analyzing you as someone who is risky. And so if you want people to buy your bonds, you will have to compensate this bad reputation you have with a higher interest rate for the bond. Okay, that's a problem because, for example, in the 2008 and following in Europe, there's been a bond crisis for a sovereign debt crisis, okay, because of notably Greece, who was supposed to be quite certain. We understood that Greece was maybe a little bit, making up the financial statements of the country, and so it was not so easy for them to pay their debt. And then suddenly the rating of Greece has been going down, and so they had to pay higher rates for their bonds, right? So what does it mean? It means that there was much more credit spread, right? Which is the difference between the yields on corporate bonds and treasury yields, or government bonds and treasury yields. So here on the chart, you can see the yield to maturity, which is offered by US Treasury, okay, according to the maturity. We can see again the pattern with lower rates for shorter term and bigger rates for longer term. But we can certainly see the difference between the yellow line and the blue line. Blue line being AAA industries, okay? So you can see that the trend is the same, but that AAA industries have to pay a higher rate for their bonds than US government, because the markets analyze that even if they are very, very good and very solid industries, the risk is still a little bit higher that they will not be able to pay their bonds compared to the US government. And of course, when we go down in the ratings, like in the green curve, we can see that here we have simple A industries. And so this time we can see that these industries have to pay even higher rates for their bonds. Okay, so that's something which is important for companies, because if you are a company, if you want to issue bonds, of course, you're gonna have to pay interest to the people who buy your bonds. And so it means that if you are not very solid, or if your rating is not very good, it's going to be expensive for you to finance yourself on the market through a bond solution. Okay, so it's also something we have to keep in mind when you want to issue a bond. Is it something which is expensive for you or not? Okay, so that's another thing. A few charts to finish. The first one is about the spread for long-term corporate bonds versus US Treasury bonds during during a certain period, 2005 to 2015. So you can see, so this is the extra rate you have to pay. This is a spread, right? So this is the extra rate you have to pay to people who buy your bonds compared to US Treasuries. And so, of course, we can see that we have a large amount, the largest spread during the crisis. Okay, so it means that after 2008, companies were supposed to be more risky because of the crisis. Maybe they would bankrupt, so they would not be able to pay the bonds. So people who were buying bonds on the market were asking for a compensation for the risk they were taking. Okay, and so the risk was, of course, even bigger when you had a lower rating. Okay, so there was an accelerating process. If you were the blue ones, so the triple A, okay, you have a spread, you have an increase in the spread, but I mean, it's doable. When you the green one, well, it becomes, suddenly maybe less easy to finance yourself on the market. And this is exactly the moment when you lack of cash and when you have problems. So this is exactly the moment when you need financing. So of course it accelerates the probability that you be in financial problem, financial distress. Okay. So I was talking about sovereign bonds or corporate bonds, but you have also government bonds, right? And so just here for to show you, this is a figure which is interesting. I think it's in Europe. Okay, so European government bonds. And so you have several countries. Ireland is in green, Germany is in purple, France is in blue. And so from 1976 to 2012 and more, we can see the evolution of the government bond yield, so the interest rate they had to pay on their bonds, right? So you can see here that there was a lot of fluctuations, and the rates were very high in the 80s in Europe. We had a very high level of inflation at the time. Okay, and we can see that it goes something interesting here. It goes, everyone goes in the same direction around like 99 or something like this. Is there somebody in the chat who could give me what the reason why we have all these individual countries rates that goes in the same let's say same value in 1999? What happened in Europe in 1999? Of course, they joined Eurogroup. So it means, and this is very interesting, the birth of Euro, exactly. And so this exactly illustrates why politicians wanted the Euro to happen. Because from that moment in 1999, it seems that the market analyzed all the European countries the same way, okay? Because they consider that because we have a single currency, it means that we will behave only like one person. We have the same patterns, the same risk, okay? Or maybe that we will help each other, something like this, if there is something that happens. And so this is what happens in 1999. All the countries now have the same rate. So if you look what happening before, like Ireland, for example, Ireland was very much higher than Germany, for example. And now, thanks to the euro, we could say that Ireland was able to have bonds with a lower rate, right? So that's interesting. So it goes during a certain number of years. And then here we can see 2008, the sovereign debt crisis. And we can see that this is a moment when Greece appeared to have um, to have a risk of default. And see what happens from 2008. The curves are separating, right? What does it mean? It means that the markets at the time understood that maybe Greece or Portugal or Spain would face a large crisis, maybe when Germany was more okay. So it means that they understood that despite the birth of euro, to just read the sentence of Tong, despite the fact that the birth of euro, the risk of default was still at the country level. Okay, so it's not that because we have a single currency euro that Germany will help Greece or France will help Greece and so on. And so from that moment, the markets understood that when there is a moment of crisis, Germany and France did not help Greece to face the situation. And so it became very much more complicated for some countries like Portugal, Ireland, Italy, Spain. So globally, all what we call, the Mediterranean countries and Ireland. Greece is not there, and we could see that here, France and Germany were doing quite okay, and we can see that the central banks have been, decreasing the rate of the central bank to be able to have an influence on the rate. This is another expression of this the same thing. It's in French, but you can see that the green one is Italy, the dark one is Spain, and we have red is France, and brown is Germany. And you can see that after 2010, okay, this one goes up and this one goes down, but still there is a little bit more risk for France than for Germany. Okay, so that's why we say usually that Germany is the risk-free rate in Europe. Okay, so I just wanted to show that to you. So we are done with the chapter about bonds. Do you have any question about bonds? In reality, how the issuer can determine bonds coupon rates and its maturity? Well, you can use history, you can use statistics, and you can use some perspective. You use also your rating, okay? And then you go on the market. But there is always a risk that about the coupon rates, that maybe when you issue your bond, the markets will analyze the situation to be not very interesting, so they will not buy your bonds. So it can happen that for example, France, the country of France, they lost the AAA a few years ago. So they were very afraid that they would have to increase the coupon rate to be able to sell their bonds. But finally, they were still analyzed to be quite sure, so they didn't have to increase much their rates. So they were issuing bonds as a rate which was correct, and people were still buying. And one thing you have to understand also is that I think at the country level, I think it's like every week or every month that bonds are issued, okay? So I think it's the third day of each month that France will come on the markets to issue some bonds, okay? So you can correct from one month to the other. About the maturity, it depends, but usually the normal maturity is 10 years. Actually, I think the issuer can decide bond coupon and maturities themselves, then the market will decide the YTM based on the risk premium. Well, actually, yes, to some extent, because as I said, maybe they will buy or not buy. And so for the next issue, that it will correct. It depends on if the bond is issued with a fixed interest rate or not. Okay, and sometimes you have packages for which when you issue something like at the company level, you will have some issue some bonds which are issued at a fixed rate, other which are issued at a variable rate, and so this is when I think people can adapt. Yes, yes. This is the issuer. Huh? This is the issuer that decide the interest rate and the maturity, huh? Of course. But what they do, they will try to choose again a rate and a maturity that they think the market will accept. Okay. And again, if they do not, what happens is that your company or your country will have bonds which are not sold, right? So that will be, that would not be a success. The operation will not be a success, right? Because people did not buy the bond. So of course the issuer is choosing the rate and the maturity, but they choose the maturity and the rate, so the operation is at the end of the line a success. So this is what they try to do. Is that okay for everyone? Yeah, you're welcome. Thank you, Hien, for the additional information. And thank you, Hang, for your question. Okay, so if you do not have any other question, maybe we have time for 1 or 2 exercises, like 15 minutes. And so we have the time to introduce the next chapter. So maybe you can go and see bond valuation exercises and just do exercise number 2 and exercise number 5. Okay, exercise number 2 and exercise number 5. Okay, so I'll let you 10 minutes to do this and we discuss the solution together. You can share your your answer, of course, in the chat always. It's 134 and not. So for the first one, you have to search for the rate, and so if the price is 1,034.74, so it means that the bond is quite interesting. It quotes at a premium. So it means that the coupon rate must be more interesting than the yield to maturity. So the yield to maturity is certainly less than 8%. And since it's semi-annual, so you have to take in your calculation less than 4%. Yes, so I begin to have, I think 375 is correct. Yes, 375. That's correct, Trang. 7.5 for the annual. Yeah, 375 ha, it's correct as well. Do not forget to multiply that by 2 to find the annual. And 8B for Kien, you have 934. Yeah, that's correct. 5 more minutes for everyone for this case, and I correct. That's correct, Trang. Thank you for sharing. Do not hesitate to share your answer in the chat, even if some people did already, so I can identify the people who finished the exercise and maybe have an idea about who is comfortable with everything. Thank you, Chang. Thank you, Hien. Thank you, Liam. So you have the number 5 you can do afterwards. I know my explanation about the linear interpolation was a little bit tricky and maybe complicated. Again, you don't have to go through this calculation if you don't need to. I don't care. If you have another way to do it, it's okay with me. If you know that you will have the video, so you can look again if you have a doubt about it. But hopefully, if you now are more comfortable with these 2 exercises we are just doing now, well, it means it's more, it's more easy. Yeah. Okay, so I just take the lead for the exercise number 2. So exercise number 2, suppose 10 years, 1,000 bond with 8% coupon rate, semi-annual coupons is trading for a price of 1,034.74. What is the bond yield to maturity? So as I said, since we have a price which is higher than the face value, so it means that the yield to maturity must be lower than 8% on an annual basis. So you can already try with less than 8%. And do not forget to divide that by 2. And so actually, so it doesn't say the solution, but it's 375. Okay, 375 on a semi-annual basis. So it's 7.5 on annual basis. Okay, so it shows directly. So it's 375. We have it here. 375. Therefore, the YTM is 7.5. 7.5. By the way, you have the formula if you want to use Excel, but in the exam you don't have Excel, so maybe don't make it too much on Excel for the moment. Second question, now it's easier. If the bond yield to maturity changes to 9% APR, what the bond price will be? So here, so it means that we take 4.5 for the YTM, okay? And so that's easy. We can calculate now. It's easy to calculate. This is a formula we know now. So it's 934.96. So we can see again the illustration of the fact that in the first place, the price is higher than the face value, and we have yield to maturity, which is lower than the coupon rate, 8% coupon rate, 7.5 YTM, okay, here. And on the contrary, when it goes 9% APR, so it means we are higher than the coupon rate. So it means that the interest rates on the market are more favorable than the coupon rate. So it leads to a price of the bond which is at discount, so 934. So I see on the chat some solution already. So Ha is okay for the exercise number 5. Trung is okay for number 5. Luong found also everything about number 5. Dong is on its way. 2 first questions are correct. Kien, same. Okay, so I'll let you 2-3 more minutes to do exercise number 5, and we correct. So we have 15 minutes to introduce tomorrow's topic, as I did yesterday. By the way, before I forget, I gave to Kiolin the PDF version of the exercise for time value of money and interest rates with solution. So it's already in the files of Canvas. I don't know if you've seen that. And so today I will provide her with the PDF version of the solution to the bond chapter. So if you have a doubt, you can check already, okay? Okay, so let's have a look at number 5. Suppose that General Motors Acceptance Corporation issued a bond with 10 years until maturity, a face value of 1,000, coupon rate 7%, annual payments, so easier. Yield to maturity on this bond is actually 6% was 6% when it was issued. What was the price of the bond when it was issued? And then what is the price of the bond immediately before and immediately after the first payment? So these answers. So what is the price when it was issued? So we don't have all the details of the calculation, but you know how it works. So it's 173.60. Okay. Before the first coupon, well, you have two ways to do that. You take 173.6 times 1.06, right? Or you can just say, okay, I do this one before the third question. After the first payment, I know it's 10 coupons to go, and then I add it back to the first one, okay? So we can see here, the way it's written, it's interesting. So this, you know, it's the same formula, except that we add the 70, okay? So globally, we have 138.02 and 168.02. And as I said, you have two ways to do question B, or you do question C before and then you add the coupon, or you do directly question A times 1.06. Okay. So I understand, I could feel today that there was one moment it was complicated for everyone, because for me it was maybe the explanation was not so easy to give, and maybe for you guys it was maybe also not so easy to follow. But now that we finish your chapter, you can see the global perspective for bonds. Finally, it's not so complicated. So let's not focus on the interpolation that we did. Okay, let's say that's a plus, a little spice. But for the rest, we can see now with the exercises that we have always the same pattern. And that's why I also took some time to work on the first chapter, time value of money, to work on before after thing, because I wanted you guys to get prepared, okay? And we can see that we find the same patterns, okay? And now we're gonna begin with the stock valuation chapter, and we will see that it's always the same thing. We always have cash flows in the future to discount today. The only thing that will change is the name we give to things. Like, for example, in the bond chapter, the discount rate that we use is called the yield to maturity, which is a reality, huh? This is reality. But as you know, let's not be impressed by the vocabulary. We know sometimes when we work in companies, we always have these people who are very strong, and they use very sophisticated vocabulary because they want, you know, to show that they know much. We don't care about that. What we need to understand are the patterns, and believe me, the patterns are similar when it comes to bonds, stocks, or loans, or whatever. It's just that we have to understand what are the cash flows in the context, what is the discount rate in the context, but then afterwards, it's always the same thing. It's always calculating the present value of the cash flows you expect to receive from your investments. Okay, it's not more complicated than that. Okay, so keep that in mind. And do you have any question about this exercise 2 or 5 in the chat? I see a lot of good answers here. So I'm optimistic about the fact that maybe it's more clear for you now. Again, if I were in Vietnam with you, I could see that, I could read your faces. Usually that's the best way to see if people have understood, but it's okay, so we can move on. So stock valuation now. So let's introduce, thank you, Chang, for the feedback. So stock valuation, chapter 9. So chapter 9 of the book, okay. So again, as I was saying, we have the same pattern, but with different names now. So in this chapter, we're gonna use some theories and apply them, okay? Yes, Jan, I agree with you, but maybe next year, hopefully I can come, and very often when I come to teach to the new batch, the second year batch is also around for another class. So maybe we will have the opportunity next year at least to have a coffee during the breaks in CFVG so we can meet physically. That would be, I really wish that we have the opportunity to do this. But during the group works later this week, I will go into the different groups. So I will discuss with you. So we will make more acquaintances. Anyway, so for the moment, let's talk about the theory you have to catch from what I teach. So in the stock valuation chapter, so as I said, we're going to use some theories that exist. And so firstly, we're going to talk about the dividend discount model. Okay, so it's actually inspired from the Gordon Shapiro model that I introduced in the first day. And so in this academic paper that they wrote at the first place, they go step by step. So this is what we do too. So firstly, we will consider 1 year investment. So how can we calculate the price of the share if we consider a 1 year investment? So it means that you consider that you will sell your share after 1 year. Then we will consider several years, and then we will consider forever. Okay, so we go step by step. So firstly, you remember in the bond chapter, when, sorry, it's not this one. Sorry, arrêtez de partager. So that's my my personal following of the time schedule. So we are on time, if you want to know. Despite the fact that it's online, we have the same rhythm than the previous years. Okay, that's my personal stuff. So here, what I wanted to show. Yes, so you know, for stock, now we can say that we also have two types of cash flows. We have the dividend we expect to receive every year, okay? And we have the selling price of the share when we decide to sell it, okay? So we can, selling price of the share, okay? So we have also two types of cash flow, dividends and selling price of the share. Okay, so we can see that it's not so different from the bond, coupon bond. Coupon become dividend, face value becomes selling price. Just, you know, of course it's different. Of course, we are talking about different things, huh? But the logic of the calculation is the same. So let's not be impressed by the vocabulary again. So potential cash flows, dividend, and the sale of the stock. So globally, how can we calculate the price of the share today when we decide to invest for 1 year only? Well, it's the present value of the dividend in year one we expect to receive, plus the price in year one we expect to sell the share, okay? The only thing is that it's not the yield to maturity anymore that we will use, is the equity cost of capital. And you can see that it says that the cash flow, since the cash flows are risky, we will use the equity cost of capital. So globally, please let me share with you in the chat that equity cost of capital is usually higher than the cost of debt. So like the yield to maturity, for example, okay? So later on, you will learn this RE, which is the cost of equity, okay, which is also the return on equity, actually, but market value, not accounting value, okay. RE is usually higher than RD, which is the cost of debt, okay. And these RE, RD are some things you will rediscuss with my colleague Pramwan Bunkanawisha, again, when you have the course about financial structure and strategies, which is the natural complement to this course. So that's why I often talk about this one. So again, we have always this approach to say my price will be nothing else than the dividend, the present value of the dividend and the price to receive. Okay, so I can write it this way, right? The P0, so the price today of the share, is the present value of dividend 1 plus P1 divided by 1 plus RE. Okay. So if we take one, I don't know if we have one example, but let's, okay, we will see. But this is it. Okay, so if we redistribute this, 1 plus RE, we put it here. Instead of P0 and P0, we put it here. Okay, we can see that we reach this dividend 1 plus P1 divided by P0. Okay, minus P0 divided by P0, so that RE. So we can actually redistribute the cost of equity, and we can say that the cost of equity, RE, is linked to two things. What we call the dividend yield, which is a dividend in percentage, okay, of the P0, okay, plus P1 minus P0, which represent the gain in value of the share when you sell it in 1 year. So hopefully you expect to sell it at a higher price than what you bought the share, which is not always the case, of course, but that's, I mean, it could work if P1 is lower than P0 anyway. The capital gain rate would just be negative, right? But what is important to take away from the moment, for the moment, is that we have two components of the return on equity, the dividend yield and the capital gain rate, okay? And of course, the total return will be the sum of these two things, dividend yield and the capital gain rate. Suppose you have Walgreen Company to pay dividend of 1.4 per share and trade for $80 per share at the end of the year. If the investments with equivalent risk to this stock have an expected return of 8.5, what is the most you would pay today for the stock? So firstly, please calculate, and that will be the last job to do for today, of course, because we have a few minutes left. Calculate P0 and then calculate dividend yield and capital gain rate. So very easy to apply. Just apply the model that was before, and you can share the solution in the chat, just to check that we have well understood how to apply the model. Yes, Chung, I think this is correct. 75. Okay, Kian finds 75 as well. I don't want to show the solution for the moment, but I remember the number rings a bell, as we say. You can round it to two figures after the dot, because we are talking about, you know, dollar and cents. So you can make it as a percentage, 1.86%. Maybe it's easier to read. Yes, Chang, I think 75.02, it's correct as well. Yes, Ha, it's correct. And capital gain rate, 6.63, I think it's correct. Yes, Hong, you can make it, instead of 0.00186, maybe you can say 186%. So here, this is correct as well. More people from Hanoi. answering to this question. You know, you had this colleague from Ho Chi Minh City that was teasing you yesterday. I can see a lot of group 5 to 8 answering to this question. And now Huyen from group 2, so you know, representing Ho Chi Minh City with the right answer as well, 75.02. Capital gain rate is correct. I think he had 6.63. I think Tron found the same thing. Sounds correct to me. Okay, 1 more minute and show the solution. So Chang find 187 and 6.63. So I think this is correct as well. Okay, so I think this is time to have a look at the solution. So as I said, the first step was to calculate P0. So it's dividend 1 plus P1 divided by 1 plus RE. So it's quite simple, 1.40 plus 80 divided by 1085, 75.02. You know, to get, you know, beside the calculation, so what you have to understand here is that you are a potential investor and you say, okay, I'm interested in the Walgreen stock. And so then you collect information. What could be the reasonable dividend that I can expect to receive in 1 year? What could be the expected price I could be able to sell it in 1 year? So you make your, you know, econometrics about it and so on. And then you say, okay, so you have, okay, so I should be able to receive 1.40 dividend next year because maybe, you know, I don't know, this is the average of the 10 years they've been paying dividend, whatever, I don't know. Then 80, well, this is a perspective anyway, so this is a forecast, okay? And then you say to yourself, okay, but now what is the return I expect from such an investment? And then you say, okay, well, usually when I invest in stock, what I want is 8.5. So you use 8.5 to the return in equity in your formula, and you reach 75.02. So what does it represent? It represents the price you are ready to pay to buy that stock. It represents the value of the stock for you according to your assumptions. So in a perfect world, if everyone have the same assumptions, everyone will have the same value, 75.02, and this will be the value of the stock on the market, okay? And if it's not the case, well, you will have supply and demand, people will buy, will sell, and the value of it will adapt, okay? But if you are at the individual level, 75.02. Now, if you see the stock price on the market, which is, let's say, 70, okay, then for you, it's undervalued on the market. So it's a good opportunity for you to buy it, right? Because it becomes a positive NPV project for you. If the value of the stock on the market is $80, it means that you have 75, for you the value is 75, on the market is 80. Maybe for you, since you've been able to calculate the potential value of it, you should not buy it because it's more expensive than what you think it's worth, okay? So this is how we can use this formula. And in terms of calculation, of course, dividend yield is 1.40 divided by 75.02. So we need to have P0 to be able to do the dividend yield calculation. So 1.87. A lot of students found this. And among which Kian, Chang, and Hong. And then you have the capital gain rate, 6.63. Okay. And just before, do not forget to add back these two things, 1.87, 6.63, to find, just to check that you have the capital gain rate, 8.5, which is the total of it. Okay. Just to reconstruct this thing. Do you have any question about this one? Okay, so if you do not have any additional question, we stop here for today. Of course, it's 10 p.m. now. It's time for you to to rest, and we will go on with the multi-year investor tomorrow. Okay, so nothing to prepare for tomorrow. Lucky you. And so we will just go on with this stock chapter. So I thank you very much for your attention, and I wish you the best for tomorrow at work. And so we meet at 7 p.m. tomorrow to talk about stock valuation. Okay? Thank you very much. You have a nice evening. Thank you. Thank you, Mai. Thank you, Kong. Thank you, Hong. Thank you, everyone. Thank you. Thank you. You have a good day. See you tomorrow. Thank you very much. Goodbye. Goodbye. I'm closing the meeting now. Thank you very much. Bye-bye.